Hey guys, what's up? I'm here with the next topic, and this is again from the biomolecule. In case you remember what we were doing last time, it was actually about describing you how the structure of glucose has been obtained, right? So in that sequence, we did some 2-3 reactions, but there are 2-3 more left. So that's what I'm going to do. But remember, these reactions are again very important because they will tell you some very surprising and very important things about the glucose, right? But in order to do so, what I have to do, I have to draw the glucose structure back again here, so they can start comparing and looking at the reaction I'm about to show. So the glucose structure was exactly this one, right? So this is your the glucose molecule, where the first carbon is having a aldehyde, the second, third, fourth, fifth, and you have the sixth. The sixth one is in the form of CH2OH, right? And the last two had OH on the right hand side and hydrogen on the left hand side. So this is the structure of glucose. However, the fourth from the bottom has a hydroxide on the left hand side and hydrogen on the right hand side. But the second one from the up there was a hydroxide on the left hand side, right hand side, and hydrogen on the left hand side. So I hope I just made you remember everything about. But why this structure came, I told you about some of the very important things about. But in that very sequence, this is going to be the next information coming up. What this is, when the fourth, this is going to be the fourth one. So you need to pay attention what I'm talking. This is what your glucose looks like. CHO, you have CH, you have CHOH. And this one is, whole 4, but along with that you have your CH2OH, right? Now, when you react this is very important. When you react this particular compound with bromine water, remember, I'm talking about bromine water. If you remember, bromine water is a mild oxidizing agent. Let me tell you, this is a mild oxidizing agent. So because it is a mild oxidizing agent, what will happen? It can only convert aldehyde into carboxylic, not any other function, not alcohol, right? So if you remember, bromine water is a mild oxidizing agent. It is not strong like K2Cr2, 7KMNO4 and HNO3. This is mild one. So what will happen? This bromine water, if there is a aldehyde here, it will oxidize it and convert into the acid. And what this acid going to be like? And this is going to be COOH. Right, and then you have again CHOH, right, whole 4, nothing is changing right here. Then you have CH2OH, right? So what has happened? This is called gluconic acid. You need to understand, this is called gluconic acid. So what has happened? Glucose has converted into gluconic acid. And this reaction simply justifies that the glucose first carbon is nothing but an aldehyde, right? So this is, this reaction is proved that the first carbon of glucose is nothing but it is in the form of an aldehyde group. I hope I made you understand, because this is something very important for every exam you might be having this year. Another very important thing about this reaction is that, bromine water, just because it is a mild oxidizing agent, it cannot oxidize ketone. So it not only confirms presence of aldehyde group right here, but it also confirms that the first carbon is not in the form of ketone, right? So this reaction is really, really significant, proving that the first carbon has an aldehyde, not a ketone. Why? Because bromine water itself is a mild oxidizing agent. What is happening here, and aldose, let me tell you, aldose is converting into aldonic acid. Aldonic acid. Why this is aldose? Because there is an aldehyde. What this is? Ald refers to aldehyde, O refers to sugar. This represents to sugar. So what is happening? The sugar is having an aldehyde group which converts into now a aldonic acid, right? So this reaction proved that. Now let's go with the next topic, where something very important coming up, right? Okay, so now let's talk about the fifth reaction, and which is also very important, and then there will be one more left. So let's do the fifth one and try to get what the purpose of this reaction is. You have your glucose here, in the form of aldehyde, the first carbon, and then you have your CHOH, whole 4, right? This is something you have already, learned it. You have 4 over here, and finally you have a CH2OH. Now, the very important thing is that this glucose has, there are 2 types of, hydroxy group. All the hydroxy groups are 2 degree. There are 2 degree OH only. You need to understand why, because all the carbons in the middle, they are connected to 2 carbons. So all the hydroxide on these 4 carbon, they are secondary alcohol. But this one is your primary alcohol. So what I'm going to do, I'm reacting this one with a reagent, which is a strong oxidizing agent, HNO3. Let me tell you, this is strong oxidizing agent, right? So being strong oxidizing agent, it will oxidize not only the aldehyde but also to the primary alcoholic group. So what will happen? This can oxidize the last OH, and this can also oxidize to aldehyde group. So what is going to happen here? This converts into COH, the first one, and then you have your everything else back there in the same way, CHOH whole 4. So this is also converted into an acid group, and this is only possible because we are using a strong oxidizing agent like HNO3. So this reaction proves that it has an aldehyde group, which was already proved in the previous reaction, but this also proved that it has a primary alcoholic group, which is on the first carbon right from the bottom. So this proves that the first carbon from the bottom has a hydroxy group, because it can only oxidize a primary alcohol into carboxylic acid, right? So both not only the aldehyde but also the primary alcohol has converted into carboxylic acid. So what this proves to be, let me write here, this proves that glucose have 1 degree, glucose have 1 degree OH group, 1 degree OH group. 1 degree OH group. So this is the purpose of the reaction, right? I'm doing the last reaction where I'll be, again explaining, something very important about the structure of the glucose. So let's take that, chemical reaction. We do know that a glucose, this is like, something you are, like something not new to you. So this is what your glucose is, CHOH whole 4, and then you have last one, add CH2OH. Okay, now what I'm doing here, I'm reacting this one with acetic anhydride. I'm reacting this one with acetic anhydride. Just pay attention, this is really important. So CH3, COO, and again CH3COO. So this is your acetic anhydride. This is something very common, as you've been doing this for so long, so you probably know that. Now another thing is that this reaction is carried out in presence of pyridine. This reaction is carried out in presence of pyridine, right? So what you are doing? You are reacting a molecule of glucose with the acetic anhydride in presence of pyridine. I'll tell you the role of the pyridine, but after you finish the reaction, right? So what happened here? What you see is that that this anhydride can undergo cleavage either from this bond, or can go cleavage from this bond. So let's break any bond possibly we can do. So if this is what is happening, this oxygen will come out to be as a negative radical, and this will come out as a positive radical. You are like very expert of doing all that. So this is a electrophilic center, and then you have your nucleophilic center. Now what you have to do, you do know that this hydrogen will also come out as a positive, and again this hydrogen will also come out as a positive. So this hydrogen, just pay attention, and similarly this oxygen will be a negative, again this will be a negative. So what I'm doing here, I'm reacting both of these hydrogen with the negative part, here. So this will convert into an ester. So what is going to happen? Let's place it back here. So CHO, and you have your C, what will happen? This is your CHO, and this CHO will come out with the acetyl group. So what I'm going to do, I'm going to place it, C, this is your acetyl, so this comes out to be, this comes out to be ester out here. Now again the last one is also going to be CH2O, and what will happen? Again you have an acetyl group here, right? So by performing this reaction, what this is forming here, this is called your ester, this is called your pentaacetate, this is also called pentaacetate. Let me repeat back. Pentaacetate is what you are getting here. So pentaacetate is forming. In case you have problem, let me tell you what I am doing here. This AC is representing to acetyl, and what this acetyl is, there you have. This is your acetyl is, this is your acetyl group is, right? Along with that, you also produce acetic acid, CH3COOH, right? Pay attention here, this is really important. Both of all these 5 hydrogen will go with the CH3COO, and all these oxygen, these 5 oxygen will go with the acetyl group. So this is what happens. This is your pentaacetate, and this is your acetic acid. This is your acetic acid. This reaction is not something new. You have done it already, you know. So let me repeat back everything here. What is happening? When a glucose molecule like this one react with, you know, ethanoic anhydride, right? It produces pentaacetate, and along with that it produces carboxylic acid, which is the acetic acid. But what is happening here? There are 4 hydroxy group at the secondary position and 1 hydroxy group at the primary position. Both, you know, these types of, you know, hydroxy groups are converting into pentaacetate, right? What this pentaacetate is? Nothing but an ester. So this proves that there are 5 OH group, and these 5 OH group these 5 groups are on different, you know, carbon. All the OH groups, you know, are on different carbon. You probably know that, you know, one thing from the other chapters is that 2 hydroxy group on the same carbon is very, very unstable, right? So this reaction is simply proving that all the 5 OH are on different carbon. So it proves that there are 5 OH, and second thing, it proves that all of them are on different carbon. Right? Let's get back to the pyridine here. What is the function of this pyridine? Suppose we were doing this preparation. Suppose we are doing this preparation of pentaacetate. So pyridine being a base, what is this? A pyridine is a base. Probably you know that. In case you do not, let me, you know, write this here. So pyridine is a base here. And what happened? This base react with the acid, and therefore, you know, keep the equilibrium in forward direction in order to produce this pentaacetate. So the function of the pyridine is helping removing the acetic acid and continuing the production of this pentaacetate. I hope I made you go, but the thing was, what we were doing, this was, you know, about glucose, right? And this reaction purpose was to make you understand that a glucose molecule has 5 OH group, where 1 is a primary and other 4 are secondary. But all these are on different carbons. So this is, you know, what is the motive of this reaction is, right? With that, you know, I have come to end of this very lecture. I'll say thanks for watching, and see you in the another, you know, important lecture from the biomolecules. I hope I have helped you out here, and you have definitely, you know, enjoyed every moment and have been benefited every moment, right? Thanks for watching. Good night.